Okay, so I'm doing a quick one this morning. My students had a question last night. And stumped on it. Thinking about it back of my mind. I just stumped for no reason. So it's not bad. We'll see. Okay, so it says a polynomial function f with real coefficients has the given degree and solution point. Write the function in factor form. So the degree is 3, so it's a cubic. And it's got solutions -1 and 2 plus I root 5. Those are the two solutions they give us. Then it says that, or the 2 zeros that they gave us, then it says that this is a solution of the polynomial. So this f of -2 equals 42 means if I had the polynomial plugged in -2, I would get back 42. So we can use this information to fit this polynomial, hopefully. And so we want it in the completely factored form, and I guess they want it also in the polynomial. I'm just going to take away, because once we get it completely factored, you just multiply it together in polynomial form. Okay, so one of the zeros is x equals -1. And if x equals -1 is a factor, is a 0, and I add 1 to both sides, then x plus 1 equals 0. This is a factor of a polynomial. So I can say for sure that x plus 1 is a factor. Now, if this is a factor and it's of degree 3, that means this I get 1 degree from this linear factor. The remaining factors should all be a part of a quadratic. Now, I don't know what form this quadratic will take, but if I just assume that it takes the shape of a general quadratic, ax squared plus bx plus c, then I know that this is one of the remaining zeros, so that has to be a 0 of this thing. Hey, welcome to whoever just joined. Say hello in the chat. So what we're going to do is we're just going to assume that it takes this shape and see if we can fit some data. So if this is a quadratic, one of the zeros, or the 2 zeros from this quadratic, will come from the quadratic equation, or the quadratic form. We'll do x equals -b plus or minus square root of b squared minus 4ac all over 2a. And so these a, b's, and c's are the same ones as these a, b's, and c's in this case. I know normally when you fit a quadratic, you're just using like the actual coefficients. And I'm going to split this fraction into 2 fractions. Since they have a common denominator, I can just separate them. Okay. So this is a 0. X is going to be, the 0 is going to be just like this. But I know what that 0 is. It's 2 plus I root 5. So I know that this thing is equal to 2 plus I 5. And this is 2 over 1 and 2 over 1. I don't think we need that though. Okay, so this part has a square root and this part has a square root. So they have to be the same part. And this part goes with this part. Okay, so we can break these apart of like using the addition property of equality backwards. And we are going to get b over 2a is equal to 2. And we're going to get another equation, which is square root of b squared minus 4ac all over 2a is equal to I5. So what do I want to we're going to need to use this solution point also at some point. Let's see what we. So from this equation here, if I just multiply both sides by 2a, I get negative b equals 4a. Negative b equals 4a. Actually, you know, nice is actually I can get everything in terms of b, I think. Still got that c kicking her. That's all right, we can deal with that. And then let's go ahead and multiply both sides by 2a here. Then I'll square everything. So this will give me b squared minus 4ac equals negative 1 plus 5 plus 4 squared. Okay, so let's collect these two equations here. See what else I can get. So this is b squared minus 4c equals squared. Now, I don't want to assume this yet. I know I'm like pretty sure it's true that this is plus or minus also. Like you can't just have one of these complex roots. But let's come back to that if we need it. Let's see what's left. So if I'm still stumped, I'll do another video. And then let's try and use this data that we've been given here. So if our quadratic here takes, or this is our function here, if I plug in -2, this should be equal to 42. So let's say -2 plus 1 times a -2 squared plus b times -2 c. This should be equal to 42. That's from the point that they use here. So this is -1 plus 4a plus 2b c 2. And just divide both sides by -a minus 2b plus c equals 40. Okay, so here's another equation. So let's just look through these like system of equations that I'm collecting down here and see if that's enough to solve it. So I have 3 equations and 3 unknowns. So that might to eliminate everything. Let's see. So I can eliminate all of the a's. Just have b and c. Let's try that. Let's try that. Or actually, let's eliminate this. So from this first equation here, I'm going to make this b equals -4a, and I'm going to make this substitution into the other 2 equations and see if I can eliminate this. So from the second equation, get -4a squared plus 4ac equals -20a squared. And then from the third equation, we're going to get a minus 2 times -4a c 2. Let's just simplify each of these. So what's the system here? Okay, so this is going to give 16a squared plus 4ac equals 20a squared, and then this is going to be positive 8a, so we'll get 12a plus c equals 42. So here's the second. So this is the new system. I'm going to take this first equation and add 20a squared to both sides. So I'll get squared plus 4ac equals 0. And then we'll just keep this the same for now. Okay. So this guy, it can't be sense. We can eliminate another variable. Let's make a substitution for, so from the second equation, if I subtract 12a from both sides, I get c equals 42 minus 12a. Let's try and plug that into the other equation, then we'll just have one variable. So c equals 42 minus 12a, so we'll get 4a squared minus 4a times 42 minus 12, which supposedly is equal to 0. Let's see if that works out. And let me just distribute this guy. So we've got squared minus, this would be 68. Okay, and this would be positive 8 squared. Okay, and so from that, I just some space here. Combine some like terms. So 4a squared, 8a squared, squared, 168a, 0. Okay, so for the eraser magic, just rewind if you need to. So all I'm gonna do is I'm just gonna solve this like a, all right, so let's factor out an a, and then I'm just kind of being lazy here. So 52a minus 168, 0. So either a equals 0, and we don't want that. We're going to throw that one away because we don't want this to be 0. We want that to be a quadratic. So 52a minus 168 equals 0. This is by the zero product principle. So I'm just going to only care about this factor. I think the other one gives me a junk solution for a. And so a equals 168 over 52. So let's get to the calculator. So 42 over 13. Okay, so let's try it. I'm getting a equals 42 over 13. Equals 42 over 13. Then we can use equation 1 to find b. So b equals negative 4a. So negative 4a is times 42 over 13, which is 168 over 13. 68 over 13. And yeah, I think that's irreducible. And then we can use one of these other equations. Let's use equation 3. So we've got 42 over 13 minus 2, 168 over 13, c equals 42. And so we can just solve for C here. 168 over 18 plus 68 over C equals 42. This will be 3 times 168 over 15. So we'll just subtract that from both sides. Okay, let's see here. So I'm just gonna do this on the calculator. So terrible part about like fixing everything is that if I get something wrong, same value for C. If I get something wrong, then I can't go back and like check my work. So this video may end up being a dud, but we're gonna check and see if this is right. So these look terrible. But factor term has. Okay, let's try it. So let's plug it into our quadratic. So negative b would be 168 over 13 plus or minus the square root of b squared. So it'd be 68 over 13 squared minus 4ac, which happens to be the same, so I'll just square it. 2a. All right. So let's see what we 68 squared. And then this is going to give us time to hang out all the time. Okay, so we're going to get under the radical some disgusting number. Actually, I think this may not have worked out. All the 13s will cancel. So all these 13s are going to cancel. What we're going to get is 168 plus or minus the square root of 21,168 over 2 times 42, which is 84. Okay, let's start reducing this to 2. Okay. I'm just pulling out factors here. This did not work out. Bummer. Okay, well, foiled again. I guess I gotta go to here. Come back and give this one another crack. I think I'm making a mistake. I think I need to assume that this is plus or minus here with this complex root, and then try to fit the polynomial, or fit the polynomial to that point by doing like a constant multiplier or something. I don't know. Oh well, I'll come back to it. All right, thanks for watching, y'all.